Please do not forget to bring your scientific calculators, okay? Do not forget to bring your scientific calculators. Make it sure that before you leave your house, your scientific calculator is inside your pocket. It is important more than your mobile phone on the day of the exam, okay? Is it clear?
Yes.
So do not forget to bring your scientific calculator. Make it sure that you put it in your pocket. It's more than important than your mobile phone on the day of the exam. Okay? So let's go to estimation. As I have said, in statistical inference, we just get a subset of the population, which we call the sample. We observe it, and whatever conclusions we have based from the sample, we generalize it to the population of interest. Now, one activity under statistical inference estimation, basically you would like to know how much is it in the population. Either it be the mean value of a certain variable, height, weight, blood pressure, whatever it is, you would like to estimate. And which one are you estimating? The value of the parameter. You don't estimate statistic because the statistic is what you observe from the sample. What you are estimating is the value of the parameter based on the observation from the sample. So whatever mean you get from the sample, which is x bar, that is an estimate of the population parameter mu. Is it clear? Is it clear? Again, whatever the mean that you will get from the sample, what is the symbol of the mean in the sample?
X bar.
X bar. Whatever the value of the x bar from the sample, that is the estimate of the population parameter mu. Is it clear? Therefore, the estimator of mu is x bar. The estimator of capital P is small p. The estimator of sigma is S. Am I clear? Is it clear? Uy, Shabab, I'm asking you, is it clear?
Yes.
Again, what is the estimator of mu? X bar. What is the estimator of capital P? Small p. What is the estimator of sigma? S. The estimator are taken from the sample. Okay? You do not estimate a statistic. You estimate a parameter. Is it clear? There are two kinds of estimates. Point estimate, interval estimate. Point estimate, one number only. You get me? So if example, what is the point estimate of, for example, you are 20 students. I want to know the mean age of the 20 students. What I will do, I will just get probably 5 students. What do you call that 5 students? Sample. I will get their ages and I will get the mean. What will be that mean? X, the x bar. For example, the x bar is equal to 19.2. 19 years, 0.2. That is my point estimator of the mean age of the population. So x bar will estimate the mu. Is it clear? X bar will estimate the mu. So in my example, my sample, the value is 19.2. Dr. Atik came and he asked again another sampling. He get 5 students again. His sample arrive at a mean equal to 19.6. Take note, mine is 19.2, his is 19.6. It's different, isn't it? Why is it different? Because my sample is different from his sample because of sampling variation. Do you get me? That's why our values are different. Our values are also different from the true value of the parameter. This is because of chance. It so happened that my sample are made up of these students here. It so happened that Dr. Atev's sample is made of that students here. What if one of the students here transferred here, and on the time that I am doing the sampling, he is included in my sampling? That is because of chance, isn't it? It's because of chance that he is here and not there. Similarly, it's because of chance he is here and not there. That's why he is included in my sample. Do you get me? So the difference of the value of the statistic from the parameter is basically due to sampling variation, which is dictated by your chance, because of chance. Is it clear? Do you get me? Shabab?
Yes.
Is it clear? Okay. Now, point estimate is just a single number. Interval estimate is made up of two numbers, a lower limit and an upper limit, plus a level of confidence. Do you get me? Again, what are the level of confidence that we usually use? 90%, 95%, 99%. These are the traditional ones. But you can have any level of confidence. But usually, traditionally, these are being used in research or by statistician. 90, 95, 99% level of confidence. Do you get me? Shabab? Okay. So these are the estimators. Small p for capital P, x bar for mu. Now, the level of confidence or the confidence coefficient 90 corresponds to 0.9. 95 is 0.95. 99% is 0.99. They have their corresponding CD gates. Take note of this. 90% is 1.64. 95% is 1.96. 99% is 2.58. Do you get me? Now, the corresponding alpha, later we will be discussing alpha. In relation to this, 90% is corresponding to an alpha equal to 0.1. Okay? 95% is corresponding to an alpha that is equal to 0.05. And 99% is corresponding to an alpha that is equal to 0.01. Where do I get that? How would I know? Remember, what is the total area under the normal curve? The area is equal to 1 or 100%. Isn't it? Now, if I want a 90% level of confidence, that means to say that I want the middle 90%. I will remove 5%. I will remove 5%. And so what is in the middle is 90%. Okay? Therefore, if the total area under the normal curve is equal to 1 minus 90, which is equal to 0.9, this is corresponding to 0.1. This is your alpha, the error that you are willing to forgive, 1.1. Similarly, if it is 0.95, 1 minus 0.95 is equal to 0.05. Therefore, in that case, I want the middle 95%. Middle 95%. So, there will be 2.5% remove. 2.5%, remove. I have the middle 95%. I have the middle 90%. What about 99%? This corresponds to 1 minus 0.99, which is equal to 0.01, and alpha equal to 0.01. Therefore, middle 99%, how much will be removed?
0.0.
So therefore, I will divide this by 2. 1% divided by 2, that will be 0.5%, and this is 0.5%. Take note, huh? Percent, decimal. Percent, decimal. Huh? So don't be confused with decimals and percents. Okay. Now what do you notice? As the level of confidence increases, what happened to the area under the normal curve? It becomes wider, isn't it? It becomes wider. And so the level of confidence increases, the confidence interval estimate also becomes wider. But if the level of the confidence becomes wider, or the level of the confidence increases, what will happen to the precision? What will happen to the precision? As the level of confidence increases, this leads to a wider confidence interval, which leads to a lower precision. The precision decreases because the level of confidence increases. In other words, remember the guy who will be jumping from the building? As the level of the confidence of the rescuer becomes high, what happened to the catching mat? It becomes wider. So what happened to him when he jumped? He can jump anywhere within the mat. Less precise. But if it is becomes smaller, the level of confidence becomes lower. Where will he jump? We need to make it sure that he will jump on the spot. Otherwise, he will die. Do you get me? So as the level of confidence increases, the confidence interval becomes wide, it will become less precise. Is it clear? Okay. Now, in estimation, we follow the following formula, which is very simple. So please bring your calculators, huh? Very simple. The general formula is statistic. Okay? Statistic plus or minus the value of z. Multiply that by the standard error. In the case of mean, so multiply that by the standard error. In the case of mean, that will be plus or minus z. Multiply that by sigma divided by square root of n. Do you get me? This is the standard error of the statistic. Remember, this is a statistic, x bar. Plus or minus the value of c. Where will I get the value of c? It depends on what confidence you have. If you want 90%, what's the value? 1.64. If you want 95, and if you want 99, 2.58. Do you get me? Now, since we are subtracting and we are adding the same value, we are subtracting this and we will be adding this. So for upper limit, you add. For lower limit, you subtract. Since we are adding and subtracting the same amount, where do you think is x bar? Where do you think is x bar? This is the lower limit, and this is the upper limit. It is in the middle. X bar will be in the middle because you are simply subtracting and then adding the same amount, which is this value here. You get me? Is it clear?
Yes.
Making sure it's clear. Once you get this, wherever you go, you will understand statistics. Because everything in statistics is based on this theory. You get me? Everything in statistics is based on this theory. Once you understand this, voila, you will understand biostatistics and you will start loving biostatistics. And you will become good researchers. Do you get me?
What is the N method?
Huh?
N method.
And the sample size. How big is your sample? So, again, this is the level of confidence. This is the statistic. This is the standard deviation. And N is the number of samples you have. How many individuals in the sample? How many you interview? How many you survey? How many you question? How many you measure? Do you get me? Okay. Now with this, let me just zoom in this particular formula. Now, what do you think will be the effect of the following on the CI? Please take note, when I say CI, that refers to the confidence interval. What will be the effect on the CI of the sigma? Of the Z. C is, let me just write it here. Z. CI. What will be the effect of C? C is 1.64, 1.96, 2.58. As C increases, what happened to our confidence interval? It becomes wider. Why is it becoming wider? Because you are multiplying it with a bigger number. Okay? Now, we know that C is, this is equal to 90%, this is equal to 95, this is equal to 99. This is confidence coefficient, right? But what about alpha? This is 0.1, 0.05, 0.01. What do you observe? As alpha increases, the confidence interval becomes wider. Is it wider as alpha increases?
No, decreases.
Becomes narrower. Kibir sa wider, narrower. Take note, which one is bigger? 0.1 or 0.05? I will wait, Bikiga, Bigger, 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 bigger. Right? See the pattern? Okay. So it's clear. Now, sigma. What will be the effect on sigma? 1, 2. What will be the effect of sigma? As sigma increases, what will become this number?
More.
Bigger, right? Bigger, because this is in the numerator. If it is becoming bigger, what will happen to the CI? It becomes wider. Right? Last, n. As n becomes bigger,
Increase.
what will happen to our CI?
Increase.
This is in the denominator. The bigger the denominator, what will happen to this value? It will become smaller, right? You are dividing into many.
Yes.
Right? Therefore, the effect of n, as you increase the n, our CI becomes narrow. Okay? Do I need to memorize? Just look at the formula and it will speak to you. Do you get me? Do not memorize this. Just look at the formula and the formula will tell you the answer. And the formula is so simple. X bar plus or minus z. Multiply that by sigma over square root of n. Do not memorize it. The formula will speak to you. Listen. Open your eyes. And be critical. Do you get me? Do not memorize. You think, put it in your mind. You know it already. It's just in there. You just need to search for it inside there. Look at the formula. It will answer the question for you. Am I clear? I'm telling you, if you know these theories by heart, you can go far, far, far in biostatistics. Because the foundation of biostatistics is all of this. Okay? Now let us have an example. The physician was interested in identifying factors affecting the utilization of health services in his area. Among the factors he considered was accessibility of the clinic. He interviewed a random sample of 25. Okay? And asked about the distance traveled in going from their homes to the clinic. His findings showed a mean travel distance of 7 kilometers. What is the point estimate? 7 kilometers. X bar is our point estimator of mu. That's simple. Okay? Next. So this is the answer, 7 kilometers. If we will be continuing our discussion, our problem, I want to construct a 95% confidence interval. Now, do we have all needed in estimation? It says here, a similar study done in the past showed that sigma is equal to 2.4. Construct a 95% confidence interval. We already know from the previous discussion that he sampled 25. N equals 25. X bar equals 7. It's written there. It's all in the problem. And sigma equals 2.4. Can we do our estimation? Yes, because all the elements are there. What is needed is Z. What is the value of C? Will you tell me, oh, it's not given? Is it given?
Yes.
It is not given, but you know that you need to construct a 95% confidence interval. And a 95% confidence interval is equal to 1.96. Therefore, let us compute X bar minus Z times sigma divided by square root of n. 7 minus 1.96. Multiply that by 2.4 divided by the square root of 25. That is equal to 6.0592. On the other hand, the upper limit is equal to 7 plus 1.96 multiplied that by 2.4 divided by the square root of 25. And that is equal to 7.94. We now have two numbers, lower limit and upper limit. The next question now is, how do we interpret this? How do we interpret? What is our level of confidence? 95. Therefore, we are 95% confident that the value of the mean, the value of the parameter, what is the value of the parameter that we are estimating? The distance of the distance traveled by the patients from the houses to the clinic is between 6.06, do not forget the unit, kilometers, and 7.94 kilometers. Take note, the general template is this. We are blank % confident that the value of the parameter, so